For generations, construction meant dust, delays, and the same methods repeated endlessly. Then machines started showing up that nobody saw coming. Technologies so precise, so powerful, and so efficient that entire project timelines are being cut in half. What took months now takes days. What needed dozens of workers now runs autonomously around the clock. Every machine on this list is already deployed, already on job sites, and already making traditional construction look painfully outdated. These are the innovations rewriting how the world builds. This isn't a painter. This is the Canvas drywall finishing robot, developed by Canvas, and it's changing how walls are finished forever. Watch closely. The machine rolls smoothly into position, scanning the wall with built-in sensors. It instantly detects drywall seams, then its robotic arm extends forward and begins spraying joint compound with absolute precision. No overspray, no wasted motion, just clean, targeted application exactly where it's needed. This Level 4 targeted spray system focuses only on seams, preparing walls perfectly for finishing. It works fast, consistent, and tireless, reaching high areas without ladders or scaffolding. Every spray is controlled, every movement calculated. What once took days of manual labor happens in a fraction of the time. This isn't just automation, this is Canvas turning drywall finishing into a precise, intelligent robotic operation on every modern construction site today. Deep inside this tunnel, a powerful robot is quietly transforming construction. Meet the Fisher Baobot MRS-15, developed by Baobot GmbH and powered by the Fisher Group. This intelligent construction robot moves steadily along the tunnel floor, positioning itself with surgical precision. Then its robotic arm extends, locks onto the exact point, and drills clean, accurate anchor holes into solid concrete. No guesswork, no wasted movement. Everything follows a digital construction plan. The Baobot doesn't just drill, it automatically cleans each hole, prepares anchor points, and records every drilling parameter digitally. This ensures perfect placement, maximum strength, and complete quality control. Working high on tunnel walls at extreme heights, it performs tasks that once required entire crews. Faster, safer, smarter. This is not just a machine drilling holes. This is the future of tunnel construction, working silently underground today, revolutionizing how we build. It takes off like a helicopter, flies like a fixed-wing aircraft, and maps entire landscapes with surgical accuracy. The Wingtra 1 from Switzerland is unlike any survey drone on the market. This tail-sitter lifts vertically, transitions smoothly into forward flight, and covers 1,360 acres in a single mission, from a launch pad barely larger than a doormat. Carrying payloads up to 2.7 pounds, it swaps between 61 megapixel cameras, multispectral sensors, and lidar scanners without tools. Ground resolution reaches an astonishing 0.22 centimeters per pixel. It flies at 49 miles per hour and holds steady in 27 miles per hour winds. Surveyors who once spent weeks mapping terrain now complete the same work in hours. Wingtra 1 didn't just improve aerial surveying, it completely reinvented it. Walls with no joints, concrete with no interruptions. Austrian slipform construction achieves something that sounds almost impossible: a continuously rising structure where the formwork never stops moving and the concrete never shows a seam. Aluminum panels climb hydraulically upward as concrete hardens beneath them, keeping pace with strength gained to the minute. Stainless steel contact surfaces ensure flawless dimensional accuracy through hundreds of reuses. The system adapts to lift shafts, stairwells, and towering retaining walls with equal precision. Worker platforms rise with the form. The entire operation moves as one synchronized vertical machine. Why settle for jointed, segmented concrete when you can pour a structure that rises seamlessly like a single monolithic element? Slipform construction delivers exactly that. One of construction's most brutal, repetitive jobs just got handed to a robot. Tybot is a self-propelled machine that crawls across massive rebar grids on bridges and concrete decks, scanning every intersection and binding steel with wire automatically. Over 1,200 ties per hour. No breaks, no fatigue, no complaints. Setup takes just 2 hours. And from that point, Tybot works continuously, day and night, across widths stretching up to 117 feet. No programming, no digital mapping, just raw, relentless precision. Think about how many workers that replaces on a single bridge project alone. Tybot isn't just faster than human hands, it's redefining what endurance means on a construction site. Forget everything you know about building walls. The Maxi printer doesn't pour, stack, or frame, it prints. This French-engineered mobile 3D concrete printer arrives on site and starts layering real structures. No formwork, no prefabrication, no delays. A robotic arm deposits concrete with layers as thin as 0.2 inches, building vertically at up to 23.6 inches every single hour. It operates within a 12 by 12 by 7 meter zone and keeps printing through winds hitting 37 miles per hour. What if your next building was assembled the same way you print a document? That's not science fiction anymore. The Maxi printer is collapsing the gap between digital design and physical construction, one precise layer at a time. Precision-engineered pipes don't happen by accident. They happen because of machines like this. The Apex by Die from the USA manufactures concrete pipes ranging from 8 all the way to 84 inches in diameter using a revolutionary bidirectional roller head that drives in both directions simultaneously. That dual motion transforms compaction quality, producing smoother, more uniform surfaces than traditional single-direction systems ever could. Chrome guide tubes, PTFE bearings, and a 200 horsepower motor keep tolerances razor tight through continuous operation. A 4.6 cubic yard hopper feeds the process without interruption, while optional Allen Bradley PLC automation delivers remote production data in real time. When underground infrastructure demands perfection at scale, the BiDi doesn't just meet that standard, it redefines it. No driver, no crew, no limits. Komatsu's autonomous haulage system deploys electric trucks the size of houses, hauling up to 440 tons each across open-pit mines with 0 human operators behind the wheel. High-precision GPS, radar, laser sensors, and onboard computers navigate every route, while a remote operations center oversees the entire fleet. These machines push 2,700 horsepower, reach speeds near 40 miles per hour, and never stop for a shift change. They run 24 hours a day, 7 days a week, cutting fuel consumption and slashing brake and tire wear simultaneously. Is this the moment heavy industry stopped needing human drivers altogether? Komatsu isn't waiting for the answer. Their trucks are already moving. In minutes, it can scan an entire road network and hand you a perfect 3D map. The FreeFly Alta X is a heavy-lift professional drone built for surveyors who demand speed and precision without compromise. Loaded with advanced lidar payloads from the Flux series, it captures millions of data points per second across a full 360-degree field of view, paired with a 20-megapixel camera delivering rich color detail. The modular payload system means rapid configuration changes in the field. Scan, land, process, usable data in minutes. Its autonomous workflow capability and long-range performance make it a complete aerial intelligence platform, not just a flying camera. Freefly Alta X isn't raising the bar for aerial surveying, it's building an entirely new one. The ground beneath your feet isn't always solid, and when it isn't, jet grouting steps in to fix what you can't even see. This German geotechnical technique fires high-pressure fluid jets at up to 9,000 pounds per square inch, deep into unstable soil, shattering it and blending it with cement grout on the spot. The result? Hardened soil cement columns drilled up to 131 feet deep, up to 10 feet wide, with compressive strengths reaching 1,500 pounds per square inch. No excavation, no disruption above ground. Equipment ranges from compact rigs to 66,000-pound machines tackling the most extreme conditions. Whether it's reinforcing a failing foundation or sealing groundwater completely, jet grouting solves underground problems that no other method can reach. "558 feet long, 2,200 tons, and it eats through the earth like it's nothing." Germany's tunnel boring machines, deployed on the London West Midlands high-speed rail project, represent some of the most extraordinary engineering ever put underground. A 33-foot rotating cutterhead drives forward with 5,000 horsepower and 12 million pound-feet of torque, chewing through chalk and flint while conveyors clear spoil and precast concrete segments seal the tunnel wall behind it. Every single day, this machine advances 50 feet deeper. In Chiltern Tunnel alone, crews placed over 56,000 lining segments and moved 2.6 million cubic yards of earth. Could anything else build tomorrow's high-speed rail network at this scale? Absolutely not. High above the ground, where one wrong step means catastrophe, a robot takes over. This is the CREC Bridge Stay Cable Inspection Robot, engineered by China Railway Engineering Corporation to do what no human safely can. It grips the cable with mechanical certainty and climbs, steady, relentless, unstoppable. Its precision drive system maintains stability at extreme heights, while high-resolution cameras scan every millimeter of cable surface in real time. But this machine isn't just climbing, it's thinking. It detects micro cracks, corrosion, and structural damage invisible to the human eye, transmitting critical data directly to engineers the moment it's captured. Faster than manual inspection, infinitely safer, dramatically more accurate. The cables holding up your bridge deserve more than a human with a harness. CREC just gave them something far more capable. Drilling hundreds of anchor holes in a concrete ceiling, perfectly placed every single time, used to mean hours of manual overhead labor. The Hilti Gybot ends that. This semi-autonomous robot reads BIM data, locks onto its exact position using the PLT300 digital layout system, and drills precise anchor points in concrete ceilings without the operator lifting a tool. Select the drill size, step back. Gybot takes over. Its cordless system runs for hours continuously, while a built-in vacuum captures dust in real time, keeping the site cleaner and workers safer. Every completed hole syncs instantly to the cloud for live project tracking. How many hours of overhead drilling could your next MEP installation save? Jybot already knows the answer. When roads are gone and time is critical, the M200 takes flight. Developed by SkyTech for the most extreme aerial logistics on Earth, this heavy-lift drone carries up to 200 kilograms, nearly 440 pounds, across challenging terrain with 45 minutes of continuous flight time. An intelligent anti-sway system stabilizes massive loads mid-air, even through strong winds, while a dual-axis gimbal and HD video transmission give operators real-time situational awareness for firefighting and hazardous missions. Fire suppression payloads can be deployed with pinpoint precision from the air, and one operator can control an entire fleet of M200s simultaneously. Could a single person coordinate an aerial supply chain that used to require dozens? With the M200, that's not a stretch, that's the mission. It looks like a giant fabric sausage, but don't be fooled. AceTube is one of the most quietly powerful environmental engineering systems on the planet. Developed in Taiwan, these enormous woven synthetic tubes, stretching 69 feet in circumference and 98 feet long, are dropped at harbors, mines, and farms to do one job: separate water from sludge at massive scale. A single tube holds over 1,700 cubic yards of material. The engineered fabric drains water rapidly while trapping every solid inside. No heavy machinery, no complex maintenance, just gravity, chemistry, and smart textile engineering working together. How do you clean up an entire harbor's worth of contaminated sediment efficiently? You stuff it in a tube and let physics handle the rest. Most machines get you close. The Zoomlion ZA14JE gets you exactly there. Built by Zoomlion Heavy Industries Science and Technology, this electric articulating boom lift bends, stretches, and rotates its arm around obstacles that defeat every other access solution on the job site. Watch the platform position itself with surgical precision, over beams, around structures, into spaces no ladder or scaffold could ever reach. The fully electric drivetrain runs clean and quiet, making it equally at home inside a factory or on an active construction site. Its compact footprint navigates tight corridors effortlessly, while the boom extends with complete stability overhead. Operators control every movement from the basket with total confidence. Inside a factory in Nampa, Idaho, robots are quietly rewriting the rules of construction. A BB's automated wall panel system doesn't just assist workers, it replaces the most repetitive parts of their job entirely. Robotic arms equipped with vacuum lifters, adhesive applicators, vision cameras, and fastening tools handle everything from gluing to cutting precise window openings, all driven by live BIM data. The result? Production speeds jump 38% faster, material waste drops by 30%. Dozens of panels roll off daily with near-perfect consistency. Could a robot build your next home better than a crew? A BB is already answering that question. Off-site precision, on-site speed. This system isn't the future of construction. It's already running. "10 times faster than a human bricklayer." Read that again. India's Masonry robot doesn't just lay blocks quickly, it lays them intelligently, reading BIM digital layouts to automatically account for every door, window, and wall feature without a single instruction from a worker. This mobile machine rolls through standard doorways, navigates building floors, applies mortar with precision, and places each block exactly where the digital plan demands. Every single block is tracked, feeding real-time data back for material planning and progress review. In a country facing enormous construction demand and tight deadlines, this robot doesn't replace skill, it scales it. The future of Indian construction isn't being built by more workers, it's being built by smarter machines.